Hello everyone. Today we are going to discuss a video by Ivan about the steering angle position sensor. On the wiring diagram it looks just like a potentiometer, nothing fancy. Ivan found that it has a bad ground somewhere here, and when he provided a ground externally to the sensor, everything started to work perfectly. However, then he identified that the issue is at the connector to the module, and he cleaned that connector and started to get some strange values. They were not that strange. The check engine light didn't turn on anymore, but still the video stops at that moment and it's not obvious what's going on. So let's take a closer look. On the wiring diagram, the sensor looks like a simple potentiometer. And I would like to be completely clear is that if the ground was disconnected completely, like on this figure on the right, then at this point where the sensor ground should be, we would see 5 volts, because it would come all the way from the 5 volt voltage reference. But that's not what Ivan measured. We see at 435 on the screen the measurement is 4.6 volts. It's below 5. This means that some ground is provided, but it's not adequate. Another thing that I would like to note is that by design this potentiometer cannot go all the way up or all the way down. It actually stops a little bit before reaching the zero resistance or the full resistance. So it actually looks more like this on the third figure. Now, combining it with the fact that we have some resistance at the ground connector and possibly also at the 5 volt reference connector, the proper model would look like this that we see on the figure 4. We have the full resistance of the potentiometer divided into 3 sections, and we also have R1 and R2 representing the resistance of the connectors. With the hand of the potentiometer in the middle position, we got 4.6 volts on the sensor wire signal. Ivan measured the 5 volt reference line over here and he got 5 volts. That means that in that experiment R1 was 0, and 4.6 volts is 5 volts multiplied by R over 2 plus R2, whatever we have with the resistance of the ground connector, divided by the total resistance, which is R plus R2. It should be easy now to figure out what the R2 is, because let's just multiply everything by R plus R2 and we'll get 4.6 R plus 4.6 R2 is equal to 2.5 R plus 5 R2. From that we'll see that we have 2.1 R equal to 0.4 R2. From this follows that R2 is equal to 2.1 divided by 0.4, 5.3 R. So let's say if R is 1 kilo ohm, then R2 will have to be 5.3 kilo ohm, and that is the resistance of the, corrosion that is on the connector. That would explain this result. So when Ivan found that he has an inadequate ground, he took a jumper wire and provided an external ground. And in our experiment, that would mean that not only R1 is equal to 0, but also R2 is equal to 0. So everything should now be simple. If the resistor is in the middle position, then we should get exactly half of the 5 volt reference, so 2.5 volts, and everything will work just fine. And that's exactly what Ivan observed. One other thing he observed is that the voltage on the sensor wire was going from 0.25 to 4.75 volts, as we can see at 11:38 of the video. So we see that the voltage goes from 0.25 to 4.76, which is, I guess, 4.75 for us. It means that from that information we can actually calculate how big those resistances are. If those resistances were 0, then the value would go from 0 to 5 volts, but instead it goes from 0.25 to 4.75 volts. Calculating those resistances are pretty easy. So let's say that that resistance is X multiplied by R. It has to be some proportion of R, full resistance R. So it's X multiplied by R, and XR multiplied by 5 divided by the total resistance, which is R, should give us 0.25. From that we can see that X should be equal to 0.25 divided by 5, 0.05. And because of the symmetry, 0.25, 4.75, the upper resistor over here is also going to be the same value. It's going to be exactly 5% of the total resistance. So we identify that the small resistors here are 5% of the full resistance. And how does it help? Well, for the module it helps to identify the situations when the sensor goes bad, because values like 5 volts or 0 would be out of range and can be noticed by the module. For us, it actually allows to confirm one of the data points. So remember that in the original experiment, when the ground was inadequate, Ivan got that the lowest he could go was 4.27 volts. And so can we confirm this number? All we have to do is to say, okay, with the hand of the potentiometer in the lowest position, we would get 5 volts multiplied by the resistance of that branch, 5% of R plus R2, divided by the full resistance, and that is going to be, because we know what R2 is in terms of relative to the full resistance R, so we would have 535 divided by 6.3. Let's put in all the numbers, and we will get 4.25, which is close enough to 4.27 that Ivan observed. So that looks like a legitimate number. And one more confirmation that we have an inadequate ground. Now let's go to the final experiment. So supposedly Ivan disconnected the connector and cleaned it all out and connected it again, and supposedly that fixed our issue with the ground. So we can think about, okay, R2 should be equal to 0 now, but for R1 we actually don't know. After we connected the connector again, is it still 0 or not? Because in the video Ivan didn't really measure the voltage reference line again. Instead, he noticed that when the potentiometer is halfway, he got, instead of half the voltage, 2.5, he is actually getting 2.35, as is in the video at the mark 29 minute 18 second. So you can see over here he complains that it's minus 18 degrees for the steering wheel position, not 0, corresponding to the voltage 2.35. Can we really explain that? And the only way to explain that without, you know, making some assumptions, oh, maybe the whole calibration of the mechanical components changed, is just to imagine that R1 is not 0 at this point. And how this would come and play? Well, we have a 5 volts coming in, but now they go through R1 as well. And so the total resistance is R1 plus R, and if our hand of the potentiometer is halfway, we are going to have R over 2 in the numerator of the voltage divider that we have, and we should be getting 2.35 volts. From that we can easily find what R1 should be. So let's see, if we multiply this equation by R1 plus R, we'll get 235 R1 plus 235 R equal to 2.5 R. This means that 2.35 R1 is equal to, well, let me make no mistake over here, 2.5 minus 2.35 will be 0.15, and when we divide 0.15 by 235 we'll get 0.064 R. So quite low resistance. If R is 1 kilo ohm, then R1 has to be only 64 ohms to actually give us this skewed result. So this is one explanation of what happened, that when Ivan reconnected the connector, though he fixed the ground, somehow the connector for the 5 volt reference line didn't align correctly, or there was some extra corrosion that he got into, and that voltage reference line got ruined. He really should go back and check that voltage 5 volt reference line and see if it's still 5 volts or not, because I have a suspicion that it is not.